Okay.
We will hear Roberto Ferreira da Cunha. We will talk us about prospects for a second peak in news oil supplies. It's right, Roberto?
Yes.
Okay, go on.
Can you see my screen? I think not, right? Can you see my screen now?
Yeah, we can see that.
Perfect.
Okay.
So good morning, everyone. Thanks for joining us here today at the first IAEE online conference. My name is Roberto Ferreira da Cunha. I'm a director with the Berkeley Research Group based in Rio de Janeiro. And this is part of my academic work stemming from my PhD thesis that I defended in 2017 in France in the École des Hautes Études en Sciences Sociales. And sort of a follow-up work that drills down the model that I started working on my thesis called LOGIMA, or long-term oil and gas images, for understanding the future of unconventional oil and gas supplies in the United States. The question I'm working on today, and I will go in more detail, is about the potential for a second peak in US oil supplies, referring to the first one that was experienced notably in 1970, when conventional resources reached a maximum, and they did not exceed that level for decades until the unconventional revolution, as some say in the market, arrived, and this new stack of unconventional oil supplies became economic, and then it was produced. The question then comes, what about the second stack? Will it also, how large is it? What's the resource endowment that it contains? It has been revised upwards several times over the past 10 years. How long can that growth continue? Will it eventually face a second peak based on the supply side due to resource scarcity, or due to demand side constraints associated with the energy transition and policies on the oil demand side? This is the discussion I'm interested at. Of course, this is academic work. None of the opinions expressed here are affiliated with my employer or any institution I may have worked with in the past. And also, any forward-looking assumptions do not reflect forecasts. So any accuracy is not to be taken as a statement, and certainly to be used at each reader's own risk. So the context and question of this presentation is the research problem of projecting oil supplies into the future. This chart takes the scenarios from the EMF 27 study of a series of different models, and what is it that the range of scenarios they foresee for oil supplies into the century. And we see that different families of models, from intertemporal optimization or simulation models, will come with different ranges of possible scenarios they consider, from the highest possible to the lowest possible. And we see that some models do not fit into a bell-shaped trajectory that's made notable by the Hubert model work from the 1950s. And so I was interested in the beginning in understanding what is the model or the rationale underlying these models for arriving at very different levels of very different kinds of projections. If we look at both oil and natural gas at the EMF 27, we had scenarios in which it would grow indefinitely until the end of the century, following the past trend. And we had scenarios in which it would be drastically reduced. So it seems the natural gas side was not very different. So it seems at least at the time of that study around 2014 that almost anything was possible with regards to the supplies of oil and gas. So it's brought my attention to trying to understand like what's the economics behind this. The literature review for this work begins with the Hotelling framework from 1931, a very famous economic model, and also controversial because it is very simple and its high-level conclusions do not match reality. So it is a discussion whether we need additional factors or whether these additional factors are very inherent and should be considered crucial factors in the basic model. So that was another follow-up discussion from this work on different papers. The other famous context is the Hilbert model, which is not economic. It is the fitting of a bell-shaped curve within and an assumption of ultimate endowments within the historical observations. So it doesn't allow us to understand how price or taxes or changes in technological progress affect the bell-shaped trends and the behavior of producers. And then the fast forwarding to the more recent works of Oculo et al. 2015 and Anderson et al. 2018, in which there's a discussion of the pressure decline constraint and a very interesting result that generates based on a constraint related to geological factors, the declining pressure inside reservoirs, not a property of cost functions or technology, generating a bell-shaped dark green curve on the charts. So within a Hotelling model. So then you can shock the model for taxes, for cost, for technological progress, and understand how the bell-shaped trajectory varied. So a very relevant result. That was the starting point of this research. What I noticed from this model that I wanted to work with was you will see on the charts the strictly declining trajectory for reserve additions in equilibrium. This is due to this more simple nature of the model that's focusing on the decline curve, on the pressure decline, and on the assumptions on the capital cost function. What I noticed from past works from the Hilbert literature, such as Campbell and Leiher, 1998, famous article, is the notion of bell-shaped discoveries. So there is a stylized facts around this literature of bell-shaped discoveries with a lag. So on the top, we see the time frame for discoveries, and on the bottom, the time frame for production. Also less, more erratic. And that was different than the equilibrium of the Oculus model in 2015. So one element I was interested in is noticing the asymmetric distribution of resource density, which is also discussed in the 1998 paper for conventional reservoirs. So there are the largest fields concentrate a large portion of the total endowment. And then the smallest fields, several of them concentrate the remainder. So eventually you find the largest field, and then only smaller sized fields are left. So your discoveries increase while you're learning the location of the largest fields until you find them, and then they decrease after because you're only finding smaller and smaller fields after the largest cluster is found. So this phenomenon is what I wanted to work with in Logima, and I proposed changing the discovery function F. So I introduced the first relative to Oculo, which is more simplified on the discovery exploration framework. I brought back Pindic's 1978 exploration framework with the exploratory effort variable W and the discovery function F. And unlike Pindic's 1978 work, I'm working with a bell-shaped formulation for F to accommodate the phenomenon I just described. It was first described by Euler in 1976 as the interplay of information and depletion effects. So what's novel in my formulation is to bring in a bell-shaped formulation for the function F. And then, which is to say that the derivative of F with W is initially increasing until a certain threshold, which for simplicity, I assume 50% of the endowment. And once cumulative discoveries exceed the 50% mark of the endowments, the derivative changes and becomes negative. So from that point onwards, the productivity of your drilling effort begins to decrease with cumulative discoveries. Then I proceeded to calibrate this, and this is the work that is still in progress relative to the draft that I sent. So I will share some of the results from preliminary so far. The calibration effort considered the drilling productivity report from the Energy Information Administration, which covers the 7 plays depicted on this map. The data set from this report provides us with the aggregate rig counts on each of these 7 plays and the average initial productivity per rig at each month, also on these plays. And then the total production for the play at the same month. What I've worked with is by multiplying the initial productivity per rig and by the total number of rigs, you get to the amount of new production on a given month. So if you subtract from the total production, you get to what was old. So with new and olds, by looking at, you can calculate the decline rates at each play on each month for the aggregate level. And it gives us this relatively well-behaved decline rates for on a monthly basis for oil and gas on the approximate average of 5% per month. And this is compatible with the notion that unconventional wells have very steep decline rates. I then use this play level decline rates on each first month new production to estimate the reserve additions for a given month. So if I take on one here, what new wells from January 2007 were producing, and I on 2 apply this decline rate level for that initial level, I get until 2016 when I had observations in this exercise, I get to this curve in blue. I bring it forward at the average decline rate, but to calculate a tail that goes far enough into the future. And then on 4, the area underneath the curve is the amount of reserve additions that month on that play yielded. Is an estimate, of course. And not all months display the same decline rate. So I'm using the plays decline rate on the month as a proxy. The one thing that is good from this is that it allows me to sum up all the months on all the plays and reach the total production. So this chart shows the vintage of new wells coming in on each month, how they have declined based on the play's average decline rates, which allows us to understand if I did not drill any new wells at all anymore from 2017 onwards, the estimated decline I would have from that base of wells would be projected forward, as we see here on the chart from 2017 onwards. So the black curve is a historical observation of production. So when we take the cumulative or the total amount of reserve additions estimated from all these vintages, we see the blue curve, which is consistent with the fact that when the additions are higher than production increases in the Oculo model. And when the 2014 oil price shock came, we had significant reduction in drilling, and then the estimated additions decrease. And it matches that when additions fall below production, we see production peaking and beginning to decline. So it's one indication that the estimation is going according to what we expect from the concepts of reserve additions and supplies. This is broken down by oil and gas. Just to see what I was showing in the prior chart was just oil. So you see gas follow a similar trend on the same estimation. And then with this, based on resource estimates, which are very volatile and have been revised upward each year, we can estimate how the cumulative reserve stock for the Oculo model evolved. And then what would be the delta from Oculo's model based on the estimated reserve. So the share of production relative to the reserve stock would be well behaved between little less than 5%, always below 10%. So the annual delta, we aggregate the months into years, and we see the share of the reserve endowments that's produced on each of the plays in each year is very stable. And then we take for a national average, the average of all the plays at 26.17% to calibrate the national model for the US. Of course, this is very preliminary work. There's each step I'm taking here requires careful consideration. Another element that's interesting in the calibration is that while rigs, the rig count fell from the shock in 2014 onwards, its productivity on the right chart continues to increase. So this is consistent with the bell-shaped formulation of F that understands that if I'm not yet at say 50% of my resource endowment, there's room for my drilling productivity to increase as I progress towards finding the largest reservoirs on each play. So this is the final fit of the F function with bell shapes. So the productivity increases, and then the estimated X based on the amount of drillings that took place. We see the fit and the X, the actual estimated function. So there was a good fit in the functional form that was used in this exercise. Finally, the demand side is where the model is not going to go into a lot of depth. We need to focus our complexity. So here I assume producers are price takers, and I assume they work with, they anticipate an average price for the future. So if you're investing in a well, you have an investment of say 10 years or 20 years if it's a very large investment, and you work with, you expect a certain price level for that period. So in the modeling calibration, I assume producers were working with some around $45 per barrel expectation of price for the period 2007-2015, and with the shock, the price level that was consistent with their the observed drillings, given the calibration in the first period, was that they now anticipated a price of $27. And then I project this forward by different ranges of price expectations producers may have in the future. So to finish, these are the preliminary results. When we calibrate the model, it generates not only the bell-shaped trajectory in quantities that Alculu et al. Models already had in 2015, it also generates a bell-shaped trajectory in additions by deciding on effort on the blue line on the bottom. So producers choose efforts. The optimal level is this green curve, and then the optimal discoveries take place in gray, and the bell-shaped discoveries in blue. This is for a constant price. So if producers always assumed a constant price, say in 2006, let's say $45 per barrel, and that price never changed, nothing, everything remained the same as time unfolds, this would be the curve that we would have. And here on the right side, the right-hand side is a phase diagram of quantities and reserve additions. And bringing this forward after the first calibration until 2014, and then the shock calibration for 15 and 16, I paused the model in 2017 and shocked it forward at different levels of average price anticipated by producers. So this, according to Logima, would be the optimal level of drilling. Active rigs per month is the proxy for effort I'm using. So if I anticipate $100 per barrel going forward on oil, so this is the model will factor into a price per barrel of oil equivalent. That's my level of drilling. If I anticipate $70 per barrel, that's the level, and $40 and so on. And this is, again, I maintain the convex cost function from Alculu et al. And that's the main reason, because capital costs escalate with scale. The higher the price, the more I can implement scale and bring mobilized rigs at the same time. This then with rigs, with optimal rigs, I can see what's the resulting additions that I get based on the calibration of F. So until I reach 50% of the cumulative endowment, my discoveries will grow. And that's how they grow at the different price levels. And eventually I'm going to reach the 50% mark. The largest or sweet spot unconventional areas will be depleted. So the drilling productivity will decline. So necessarily my additions will begin to decrease. And then this is the resulting quantities that will be produced under that optimal drilling schedule. I know I said this before, but I want to be very careful. This is not a forecast. So this is not to say the U.S. unconventional oil supplies will peak at the given year. It's estimated here. Quite the opposite. The reserve endowments that were employed in this exercise have been revised upwards over the past years by a lot as producers understand better than conventional formations. So with more reserves, there's room for this peak to be postponed forward and so on. So the more interesting contribution that I see here is the mechanism, the Curtailment model and framework that's underlying the generation of this bell-shaped curves. So whether that mechanism is valid, that producers anticipate an average unconventional in the US, they assume a certain behavior from OPEC, they expect OPEC to level the market at a certain price range. So if you expect a $70 level over the coming decade or so, it would be optimal for you to drill at a certain rate. And if that changes over time, as we saw in 2014, producers would reassess their optimal drilling level. And what ultimately materializes is the result of the producer's anticipation of prices at each point in time, shaping their drilling decisions. So this is the result. Until COVID, the initial outlook fared well. But this does not mean a lot. What really means is if we had reached the peak and the model had predicted the peak. So the fact that production increases does not mean that my peak is correct. If the endowment is revised upwards as it was, there's going to be more room for it to continue to increase. Or if demand side implications such as COVID come, it will lead this to decline. So it's not that we have a crystal ball here that allows us to see the future, but it allows us to understand some of the mechanisms that guide the drilling decision of producers, and then understand what different policies would entail to their behavior. So I like to take a famous quote from Gaston Berger, which says that the future is not to be guessed, but to be built. So that's how I like this model to be understood. Like it's not a crystal ball for the future, but something for us to play with prospective scenarios and understand what different policies would generate on the optimal behavior of producers. So final takeaways: the notion of geological sweet spots helps us explain the bell-shaped trajectories for the discoveries. That was not depicted on my starting point state-of-the-art model in the literature. Combining with the pressure decline introduced by Oculo 2015, it remains on my model, and it is a beautiful contribution. These two geological constraints together, so sweet spot and pressure decline, helped us explain the remaining stylized facts from the Hilbert model within the Curtailment type framework. In the context of the recent advent of unconventional oil and gas supplies, as they remain within early stages of exploration, learning over the location of sweet spots is likely to be allowing costs to decline and increasing supplies despite lower levels of energy prices between 2016 and 2019. And a second peak in US supplies could cause important changes to global energy markets and climate change policies. So this is the relevancy of this research. Thank you very much. Sorry to go over a few minutes to Gerardo, and I'm happy to take questions if there's a time.
Thank you very much, Roberto. You are in good time. Thank you for your presentation, very interesting. We are in the room only 4 people. Hello, Olivier is with us. If some of you have any question, please over the mic and make the question, because we have 15 minutes to discuss the presentation of Roberto.
Brendan, give you the floor.
So I've got two sort of comments and then a question. The first one is Chuck Mason has a paper that came out in the Energy Journal, I want to say a year and a half ago, and he looks at per well level decline. He looks at a lot of things, but importantly, he looks at per well level decline rates in Wyoming and finds that for shale plays, the decline rate starts out really, really high and then falls rapidly. And I think, by endogenizing this dynamic in your model, you may get a bit of a different pattern. So that's a paper worth looking at. And so Charles Mason, I think the co-author is Lee. And so that's in the Energy Journal. I'm pretty sure it's 2019. So take a look at that one. Then the question I had is more around sort of this setup. And you kind of waved your hands at this a little bit. Does it make sense to think about constant expectations when we have such dramatic changes in reserves? That you're modeling prices as constant, and we're seeing, an order of magnitude difference in the reserves in some respects. Price is endogenous. That's the whole point of the hoteling framework. Is that going to change? Once price can vary with some of these projections, you could get very different responses. I'm not sure if you've thought that through or not, but that's important.
Well, first, thank you so much, Brendan. I will take a look at Charles Mason paper. This I'm not aware of it, so I will look at it. Thank you so much. With regards to the question, it is very valid. The framework allows for you to introduce a more complex demand formulation, like the general hoteling framework allows. In this case, I didn't do it for simplicity, to focus more on the geological constraints and that mechanism. If you do, you can simply add a more complex demand formulation, and prices will become actually U-shaped, as in NOPU allow 2015. So just to summarize, the answer is I can do it. Like it will introduce another layer of complexity on the formulation, and then you need to calibrate the demand function. So I wanted for simplicity to imagine unconventional producers that think, okay, OPEC is now setting the price at say $70, right? They will adjust their supply there. Let me imagine like those guys from from investors. They like to look at those discounted cash flows into the future that have that they have a oil price. So sometimes they say, if you put like a change in oil price, it's going to be very arbitrary. So let's just work with $70 and see what's my break even, right? So they say like, I'll bring the break even down to see like how low would the oil price have to go so that I lose money. So that's the mindset I have when working with these constant prices, but it could be made more complex for if needed.
Thank you, Roberto. Olivier, go ahead.
Yeah. Oh,
yeah.
Thank you, Gerardo. Well, first of all, Roberto, thank you very much for your presentation. I'm sorry I missed the early beginning of your talk because I was trapped in a meeting just before. I had first a question, just a clarifying question. So sorry if I may pose you to repeat, but I was wondering what has attracted you to have a look at the whole literature from Ferreira and others, because it seems to be a literature that from France looks like a bit, how can I say, trapped by geologists, predominantly geologists and not economists. People who think that, that geology predominates everything. So I was wondering first, what has attracted you to that literature? And second point, which is more a suggestion, in fact, is related to another paper by Chuck that Brandon has just pointed at in the plenary session on natural gas. Chuck kindly pointed the fact that, in fact, we should also pay attention to the industrial organization of the service sector, depending on whether it's we know that it's controlled by an oligopoly of firms like Alberta, Schlumberger, and others, and that is small oligopoly, depending on the behavior they have for patenting the technology or allowing research, it can have an influence on the evolution of the productivity of the wells and the productivity of the fracking operations. So I think that your model is quite well adapted for analyzing and trying to investigate whether a change in this industrial structure or in the behavior of these players could have an impact. It allows to add an extra layer, but solving it numerically using mixed complementarity problems could be feasible and could be a way of enriching the discussion, provides you with an opportunity to address a different topic. So it's more a suggestion than a question. Sorry for that. And the first question was about what has attracted you to that. Thank you so much.
Thank you, Olivier, for the great question. It's nice to meet you. I have read several of your works in the past, so thank you for being here. So first, what attracted me to this research? I did my PhD with Professor Jean-Charles in CEST, and we were looking at those scenarios for the future of oil and gas supplies that underpin the business as usual, and the 2 degrees, the 1.5 degree scenario, all the models such as IMACLIM and these integrated assessment models, they need to have some kind of mechanism within them to project how a different price of oil will affect the production of supplies. So that was what I was working on. I started around 2013 when the unconventional oil was starting to get very big. So we were trying to understand if those scenarios remain the same, or if we had to have some sort of a mechanism to bring the unconventional oil in and bring supplies back up, like if they were well represented. So that was what attracted me. Then when you start looking at the literature in economics, it's the Curtailment framework that will allow you to answer that question. What if I tax oil? How will the supply behavior change? And then there are several routes within the Curtailment literature for additional factors, such as escalating costs, increasing demand, market power, right? There are several branches in the literature that trace back to the 1970s. And the one that I found very interesting was the geological constraints one from the Oculo et al. Paper and Anderson, because it started looking at some of the geology thinking that underpins the Hubert literature. So from working with consulting in my career, I was also aware of the Hubert literature and some of that logic. And I know it's not economic. So I found very interesting that the pressure decline constraint was sort of a bridge into starting to understand maybe they are onto something from their angle. Is there a way to sort of bring that in here? So that's why I noticed, like, well, what about the bell-shaped discoveries? It's related to the reservoir side. I've worked for IHS market for several years, which is where Campbell and Laer used to work as well. So I was familiar with that thinking on the reservoir sides. So that's pretty much how that idea came about. And then with regards to the service sector, I think I'm aware of it, and I think there is a fixed supply of some elements for drilling too much at the same time. So if on short notice you want to drill like twice as much or 4 times as much you were drilling on a prior month, there are not going to be enough rigs for you to do that. So the price of the rig is going to increase. And I think this is consistent with the assumption of convex costs, so the capital function, because you assume that capital costs increase more than proportionately with the scale of drilling that you do. So I think your question is, well, not perfectly, but this is a stylized model, but it is captured somehow on the convex costs. Like, or at least if asked the other way around, saying, Roberto, how do you justify convex costs? Like, where are you using that from? I would say from what you just said. So the issues in the service sector for oil and gas, that it's not perfect competition. You cannot just drill as many wells as you want at a constant price. If you try to drill too much, the rig price goes up. So that creates rising costs, which is a crucial factor for the result of the model, both in Oculus already model and on this one. Without convex costs, you don't get the bell shapes, you don't get anything. So that sort of moves the problem into the service sector. Like, are we getting these bell shapes because of the service sector is an open question.
Thank you very much. Thanks a lot.
Thank you very much, Roberto. And now we can pass to the presentation of Brandon about the intervention in the North American heavy oil market. Brandon, it's all for you. You can share the presentation. Right.
Give me a thumbs up if you guys can see the slides. Good. All right. So Roberto talked about the long run and looking forward. I'm going to whipsaw us, and I'm going to talk about the short run looking backwards. The paper I'm going to present is titled Production Controls in the North American Oil and Bitumen Markets. This is joint work with Jennifer Winter, who is the head of the energy group at the School of Public Policy at the University of Calgary. And what we're looking at is this unusual situation where the government of Alberta intervened in the oil market in North America in a way that it hadn't done in a long time. The government of Alberta, which is Canada's version of Texas, this is the way we usually explain it, is very pro-market, and they're very reluctant to interfere with private actions of firms in oil and gas markets. But there was this crisis that emerged in the Alberta oil market 2 years ago where they actually implemented production controls. And so this paper is looking at a few dimensions of this particular intervention and seeing how that plays out. And so let's start with this. And so what this graph shows is one of the key motivations for this intervention. The top dark blue line there is just your WTI benchmark. This is your standard price of oil benchmark. The dashed line then reflects what is known as the Western Canadian Select benchmark. This is a benchmark that reflects sort of a heavy, sour crude. The oil sands production usually prices off of this benchmark. And for a long period of time, we see January through, say, February 2018, the Western Canadian Select benchmark trades at a discount to the WTI. But that discount is pretty stable. It's usually around $15 to $17. If we took this time series back even further, it'd be between $10 and $18 for a decade or so. But starting in summer of 2018, we see that the benchmark, the WCS price, starts to plummet, and it starts to plummet more quickly than does the WTI. And so this green bottom line in this figure represents the differential between these two benchmarks. And so the WCS is the critical benchmark for Alberta oil and gas. And we see that, in this sort of latter period of 2018, this differential gets quite large. A differential that typically trades around $15 to $17 peaked at $45 a barrel, and prices coming out of Alberta were effectively zero for a little while. Well, as you can imagine, key producers in Alberta viewed this very poorly. In fact, they got on the news, they showed up in the newspaper, and they claimed that this is an emergency situation, that their financial sort of health was at risk, that they may be in a bankruptcy situation, because if they've got high fixed costs, this oil sands production, and very few revenues coming in because WCS prices are so low, they're in a critical position. At the same time, the Alberta government uses oil and gas royalties to fund operating expenditures. So the province itself, who is the official owner of Energy, was facing a budget crisis on its own. And so these two sort of factors, that this widening differential, motivated a government that had previously been a big proponent of sort of laissez-faire oil markets to intervene. And this intervention is known as the curtailment. The Alberta government created this curtailment policy. And what this is this is just your conventional production limit. They limited the amount of oil and gas that was allowed to be exported or be produced in the province. And I'm going to give you a couple of details in a moment. But this was a major change for a province that had a long-standing, 4 decades, standing tradition of not interfering with private actions in markets. Now, all of a sudden, they're coming in and they're telling privately owned operators how much they're allowed to produce. And so our questions are really threefold. The first one is, okay, this is going to facilitate a transfer from demanders, which are largely refiners, and I'll sort of talk about where those refiners are based, because they're mainly US-based refiners in PAD 2, to producers in Alberta, including the government as owner of the resource. What's the magnitude of this policy? How big was the effect? And we're going to use conventional consumer and producer surplus to sort of measure this. But we're also interested in the price. We know, we're all economists, we can't put in a production control and not introduce deadweight loss. That's the whole point of production control. There's this deadweight loss. We're going to transfer some to producers, but we're going to introduce some deadweight loss. So we want to know what the magnitude of that deadweight loss is at the margin, because this gives us an ability to compare across jurisdictions. The Alberta market is of a certain size, and so when we calculate our producer and consumer surpluses, we're going to get a number. Maybe that number is big or small for Alberta, but it could be tiny for the US shale plays, or it could be huge for, say, the Norwegian plays. But this price is comparable across markets. And so this is sort of one of the things we're aiming for, this marginal price of this transfer. And then sort of as an interesting sidebar question, this last piece, we want to know, okay, the government set this curtailment rate, this production limit rate, and it was 8.7%. They curtailed production by 8.7%. But what if their objective was really to maximize producer surplus? What rate should they have picked? If they were optimizing, if they're acting like a cartel. And it turns out the rate should have been much, much higher. And so these are our 3 main questions. I've got a couple of slides at the end. I might just skip over on other dimensions, but this is sort of where we're focusing. And so this is a map of the region that we're talking about. And so Alberta is the province, like a state in the US, in the middle there. And the majority of the oil sands region, the bulk of the energy producing region in Alberta is up in sort of where that small C is, the Fort McMurray region. And so this is an unconventional heavy sour product. It's a very viscous product. It often has to be blended with a condensate just to ship it through pipes. And there are 4 main pipelines that exit Alberta. They're given by the red Enbridge main line, which is the number 1, that light green line that basically runs over top of it, which is the Keystone. And so the Keystone XL would have been an expansion of that project. That project subsequently been killed by Joe Biden. And so, those are the 2 largest pipelines. There's also the Spectra Energy Pipeline, which is given by the light pink line running south. That's a bit of a smaller line. And then there's the dark blue line running to the Pacific. That is the Trans Mountain. The other pipes are pretty small, or they're regional specific. Now, critically, this figure also shows you some of the refineries in Alberta and Saskatchewan. And these refineries are tiny. They're tiny. So Alberta produces roughly, let's say, 4 million barrels per day. Now it's actually about 3.5 million barrels per day. And they have a refining capacity in the region of about 500,000 barrels per day cumulatively. And so the vast majority of the product in this landlocked region is exported. And it's exported largely to refineries in Indiana, Illinois, Wisconsin, PAD 2 of the United States. And so that's a critical piece to this, that you've got some refineries in the province, but if you drive up the price of the product, you're not going to disadvantage them to the same extent you're going to disadvantage the refineries in the US. And so this gives you a bit of a landscape, but this gives you the motivation. And so this figure comes from the 2018 government budget in the province of Alberta. And so that dark line that is solid and becomes dashed is the projected heavy oil production in Western Canada. This is almost exclusively from that Fort McMurray region. The colored bars then reflect the pipeline capacity in the province. And you can see that, come 2019, production exceeds pipeline capacity. And so you've got this bottleneck in place, And with this bottleneck in place, producers have to compete to get on the pipeline. If you can't get on the pipeline, you've got to substitute to another means of transportation, or you have to put your oil in storage. And so we've got really two things happening here. That one, you've got to substitute to another means of storage, but at the same time, storage is essentially evaporated, that it is at its max in the province. And so we've got more production than we have infrastructure to take that production away. And so the main means to move oil outside of pipelines is by rail. And so we see that this is the crude by rail shipments in Alberta, from 2012 up to 2018. And you see that spike right before that the curtailment is announced. This production limit is announced. Crude by rail, they were moving 360,000 barrels per day by rail. Now, a couple of comments on crude by rail. First, it's significantly more expensive. It's up to 4 times more expensive per barrel to ship by rail than by pipe. Second, it's incredibly dangerous. And so Canada had a major accident about 6 years ago known as Lac Mégantic, where a train carrying crude essentially leveled an entire town because it was in sort of a derailment. Third, it turns out that we don't actually have the capacity to ship more oil by rail as it is. We don't have the rail cars available to actually fill them up. And so, at 360,000 barrels per day, we were actually shipping rail by truck as well, because that was the only way to ship oil, ship product. And so we've got this real infrastructure bottleneck. And so, this policy sort of all led to this situation where there's just too much production in the province for our ability to take it away. And so the government stepped in and said, okay, and they stepped in December of 2018. Then Premier Rachel Notley announced on television that we are going to limit the amount of oil that producers are allowed to produce. These are privately owned, investor-owned companies. They are not state-owned firms, starting at the first of the next month. And so the initial curtailment rate was 8.7%, that they were going to reduce the amount of oil coming out of the province by 8.7%, or 350,000 barrels per day. This rate was revised monthly by the Minister of Energy, and so you would get they would release a bulletin on a month-to-month basis saying, it's 8.9% today, or it's 8.1% this month. Each firm, each operator was allocated the amount of production they were allowed to produce, but you need to be a large firm to actually be covered by this. Initially, you had to produce more than 10,000 barrels per day. They revised that in June of 2019, where you had to produce more than 25,000 barrels per day. And so we're really not talking about a large number of firms. At the end of the policy, it was 16 firms were covered. Critically, allocations were tradable. And so I'm not going to talk about this today, but that actually solves one of the misallocation problems coming from pipeline regulation in Canada. The way we regulate pipelines as common carriers, and the way we do apportionment. But this tradable allocation was really quite a clever mechanism. That's a future paper. They also, in October 2019, exempted crude by rail. And so if you were willing to ship your product by rail, you could produce as much as you wanted. And this was really to appease one particular operator, Imperial, which is owned by Exxon. But these are some of the details, and there's other pieces at play, but this sort of covers it. So what happened? Well, this is production in the province. And we see that production peaks in December, it actually peaks in November of 2018. And at the curtailment, production does fall. It declines by that 8.7%, or it declines by more than 8.7%. But interestingly, and this is a bit of a puzzle that neither Jen nor I have been able to get our minds around, that dark line, that's the cap. That's the curtailment cap. And the province never even approached that cap following the announcement of the policy. That producers in the province managed to curtail their own production and do it in a way that they're not risking breaching that cap by a sizable margin, that the cap ticked up because producers actually reduced the amount they were producing by more than they required. There was overcompliance with the policy. And that overcompliance persisted at least until the COVID pandemic was announced, and they announced that they're going to eliminate the curtailment policy. This is a very short-run policy. But this is sort of an interesting development, which I don't have a good explanation for at this stage, other than maybe some industrial organization sort of focal point type story. But that's not all that convincing. Now, the objective of the policy, or at least the stated objective of the policy, was to reduce the differential with the WTI. And so these three lines just show you different benchmarks coming out of Alberta. The green line is that WCS I started with. The pink line is the Edmonton par price, which is a light sweet crude. And we see that the differentials spiked for all of these different blends, and they essentially fell back down to normal ranges after the policy. And so the objective of the policy was achieved. But we're economists, saying that the objective was to reduce the differential. We could equally say the objective was to transfer funds, transfer surplus to producers in the province. And that's largely what happened. And so, we want to think about this trade-off. And so I've got my classic supply and demand curve here. If we think about the way this production limit works, if the initial equilibrium is at Q star, P star, and then we're going to mandate that production cannot exceed Q hat. Well, that's going to drive the price up to P hat for demanders. And remember, demanders are refiners here. This is going to facilitate a transfer that equals that rectangle of size A there for producers in the province, for suppliers. Now, suppliers are going to have to give up that triangle C. They're going to have to give up a little bit of producer surplus. But as long as A is larger than C, they're better off. And so the government's choice, if they're acting like a monopolist, they want to make A and C roughly the same size. But if we're looking at this from a market perspective, well, we know that the loss to the market is actually greater than C. The deadweight loss from this production control is B plus C. We're losing both on the consumer side, or the refiner side, and the producer side. And so, Jen and my research question is, okay, how much are producers gaining? How much are consumers giving up? And then what's the difference? Because that's going to reflect the deadweight loss. And so we approach this, using our traditional sort of consumer and producer surpluses. But in order to sort of facilitate comparability across markets, because, we fully appreciate that not everyone is as well versed in the Alberta oil sands market as Canadians are, we actually want to know what the price of this transfer is. And we measure this price by measuring the change in producer surplus relative to the change in consumer surplus. And we just sort of get this by applying the implicit function theorem to a transfer surplus curve. It's pretty straightforward. And this sort of gives us a price of the policy. Now, in order to sort of calibrate all of this, we need to come up with some elasticities. Turns out that there isn't a heck of a lot of research measuring the elasticities of supply and demand for landlocked Alberta oil sands. And so, we set up our conventional, supply and demand system. We get our instruments, and so we've got a number of instruments for the demand and supply side, and we specify some functional forms to try and infer some elasticity of demand and supply. Key challenge with the econometric exercise, and I'm not going to spend too much time talking about the econometrics, is that we've got a really short time series, and there's reasons for that, mainly that the Alberta or unconventional production really ramped up. And so historical production does not actually reflect the current market very well. And so we want to keep our time series really constrained, 2016 to 2019. And so we've got a really limited number of observations. Plus we're using instruments. And so we've already lost a little bit of precision. And so while we get some pretty reasonable elasticities, we think they're incredibly imprecise. We don't have a lot of precision in our coefficients. And so the elasticities we get are at the bottom of this table. So for elasticity demand, we're roughly at negative 0.2. And this is a short-run elasticity demand. Short-run elasticity supply, we're at 0.1. But again, these aren't precisely estimated. They seem reasonable, but we really wanted a little bit more confidence that these values made sense. And so we went to the literature and went through a number of papers and obtained a whole range of elasticities. And this is a subset of the ones that are reflected in the paper. but we're pretty confident in our values at the end of the day. If we think about the elasticity of supply, Killian, Bornstein et al., Baumeister and Hamilton, if they're 0.1, 0.15, the Caldera et al. 0.08. Let's Killian has a paper out recently where he thinks the short run elasticity of supply is 0.03 or the 1 month. And so, we're pretty comfortable with this, 0.11 elasticity as being at least our benchmark, and we're going to do some sensitivity around that. Likewise, the short run elasticity of demand, it's hard to get elasticities for crude oil, especially for oil sands. But if we sort of think about, it being a derived demand from gasoline, at least in the short run, we're sort of in this space. And so we're going to use this negative 0.2 as sort of our baseline. And so we think we're okay, even though, our econometrics are highly imprecise. We think we're okay on sort of where the elasticities come down. And so these are our main results. If we focus on that top line where we've got a linear demand, linear supply, the bottom line just assumes different functional forms. We've got a couple of assumptions on how we're benchmarking things. This curtailment is 8.7% reduction in, required reduction in production, led to roughly a $700 million per month increase in producer surplus. That's pretty sizable for a province like Alberta. In fact, it's about 2.5% of our provincial GDP, of that province's GDP. And so, this is a meaningful contribution to that economy. It came at a cost of consumer surplus, and that cost was roughly $800 million. This means that refiners, largely in PAD 2, gave up about $800 million per month. 800 million minus 700 million gives you about 100 million in deadweight loss. That's a non-trivial deadweight loss. But interestingly, the price is roughly 30 cents per dollar at the margin. And so if we wanted to increase producer surplus by another $1, the marginal deadweight loss would roughly be about 30 cents. So we would need to take $1.30, not quite, $1.35 or something from a consumer to give producers another $1. And so, it's a pretty costly program at the margin. Now, it turns out that the consumer surplus and the producer surplus numbers are pretty constant, but the marginal price is actually really sensitive to our functional form and elasticity assumptions. And so we're not that confident on that in the same sense we are on sort of the absolute magnitude. For instance, if we look here, if we assume a different set of functional forms, isoelastic rather than negative exponential and linear, we just vary the curtailment rates. The marginal deadweight loss seems a lot smaller. Likewise, if we play with the elasticities, we can get marginal deadweight losses ranging from 0.07 cents per dollar to almost 50 cents per dollar. And so this price is harder to pin down without sort of a lot of confidence that our functional form and our elasticity assumptions are spot on. But if we play with the change in producer and consumer surplus, they're all in sort of that same $600 to $800 million ballpark, which we're pretty comfortable with. Now, I'll wrap up here. This will be my last sort of results slide. If we were thinking that the government wanted to maximize producer surplus, completely ignoring the consumer side of the market, what is the rate they should have set? Well, they should have curtailed production by 25%. And if they had done that, the maximum amount of producer surplus they could have achieved is roughly $1.2 billion. And so they aren't that far from that. They're far from that on the curtailment side, but they're not that far from that on the actual producer surplus side. It's not that big of a jump, but the lost surplus to consumers is huge. You almost triple the foregone consumer surplus. And so, it's an interesting dichotomy when you're thinking about this distribution piece here. And so I'll end here, but sort of the big four takeaways are the curtailment achieved its objective. It reduced this price differential. It increased producer surplus and government coffers. I think that's an important subtext. But the loss to refiners in the Midwest was big. This is a lot of money, $700 million per month. That is a chunk of change, or $800 million per month. But I think more importantly, and this is sort of one of the messages that we hear from investors, that this change in perspective where the government is willing to intervene in a market where it historically been hands off, really shades how investors view their participation in this market. Can they trust that the government is going to let the market determine outcomes? Or is this going to be a situation where they're going to sort of be hands-on from here forward? And, I think that's a really big question, and it's one that I can't answer. I can speculate on, but it does mark this shift in perspective for this region. I'll stop there. I'll take any questions if there are any, and thank you guys.
Thank you very much, Brandon. Very interesting too. We have in my country a large experience in the intervention of the market in a country that not believe in the market. But Roberto, Olivier, you have comments, questions to Brandon?
First of all, thank you very much, Brandon, for this extremely interesting talk. And I really like the way you have played with implicit function theorem to derive closed form expression for this welfare variations in the welfare, and I found them extremely interesting. And I have a suggestion for you, which is to apply them to the cases, because I'm working on a case at the moment, which is a case of policy intervention and highlighting the possible effect, which is the embargoes that were decided on the shipment of methanol from Iran. And I'm currently working on that. So far, I've had some evidences that it created some impact on prices, at destination markets in China or in others, and asymmetric effects in China and others. And I think that your framework in terms of playing with the social welfare metrics and how to measure this, the welfare impact of this kind of policy interventions will be extremely valuable in that case. And I would be happy to discuss that if you had a chance to in the future. I'm finishing the organization of the IAEE because I was trapped in this organization this year. And once I will be back on time to have time for research, I would be delighted to discuss that with you if you are interested in, and if that's something.
Sure, I'd love to. I'm on sabbatical starting July 1st, so I've got time.
No, that's because I think it's a very valuable way, and it's a kind of methodology that you have had. It's quite generic and could be applied also to this kind of measuring policy implication for this type of issue. So I will be delighted. I'm wondering, do you have a paper on that yet, or have you published it?
Yeah, so Jen and I posted our first draft. It's actually on the USAEE working paper series right now, and so you can find it there.
Okay, thank you so much. I will have a look, and I will put that to you, because I think it's a very valuable and interesting way of looking at it. I guess that you are now about to send it to a journal. Maybe it's already circulated, so let's keep the finger crossed.
It has been submitted. We haven't heard back yet, so. Yeah, send me an email. I'm happy to.
I'd be delighted to, because I think it's a very valuable thing. Sorry for the lack of having more questions, but yes, I was wondering that it's interesting.
Thanks. All right.
I have just a quick comment. Brandon, great work, and in line with what Olivier said, that this analysis could also be very interesting for Brazil. I'm not sure if you have been following, but there's an active debate here on the government control of Petrobras, and whether Petrobras sets the price of oil-derived fuels in Brazil at different levels than the international parity. So I have never seen quantification of the deadweight loss from these transfers as you are working with. So this methodology would also be very interesting for the debate in Brazil, to put numbers on how much is lost when you transfer, right, surplus from producers, or in our case away from Petrobras, right? So it would be the other way around. So anyway, we measure this, like it's very interesting.
So I think that, I very, very loosely understood what's going on there. But based on what you're saying, I think that there's actually sort of more richness there than there is here. If we think about Petrobras being a firm with market power, and the way that that is measured, you've got sort of the two deadweight losses that you're going to sort of think about. You know, the deadweight loss from increasing prices above the competitive one because they're acting like monopolists. Then if you relax that a little bit, you can shrink that, but maybe there's something on the other side. I'm not sure. I don't know the situation well enough, but you could sort of think about sort of even a richer model. You know, this is where Olivier's comment on the IO of the sector really becomes important.
Mm-hmm. Yeah, here in Brazil we have the two cases. So it's a rich example for you. On the natural gas market, Petrobras has been accused of being a monopolist and keeping the price of oil, the price of gas at parity with oil-derived fuels when the actual cost would be much lower. So here's one case where you can measure the keeping the price above costs. With the cost, and then you have the other example on the oil-derived fuels. Prior to 2014, Petrobras controlled prices below the international parity to preserve just the inflation, any objectives the government had. And there was a famous truck driver strike in Brazil when the changing government, a new administration did not anymore peg the control or freeze prices below levels. And then the prices began to fluctuate a lot and the truck drivers went on strike. So then you have the two cases. It's probably a rich example for your methodology.
Okay. Your mic is closer. You like?
Yeah, I know I've gone too long already, so I'll take a look.
Thanks.
Okay. Now it's my time. I will share a story of intervention in non-conventional field in my country, in Argentina, that was presented as a big opportunity for the economy of the country to get out of the big problems, big macroeconomic problems, and present these resources as the opportunity for Argentina to be will be player in the international oil market and in the most and this in the energy NGL market too. First of all, the non-conventional resources in Argentina was informed by the Energy Information Administration of United States in 2012 in 280 giga cubic meters, second place in the world, and the oil technically recovered resources in 27 gigabarrels, placing the country in the first place in the world. You see the proved reserves in Argentina are much lower than this. The ratio between CRR and proved reserves is very, very high and fit the expectative of these possibilities. The field is in the southwest of the country. You have in the Neuquén province. It's a productive basin, an historical productive basin in the country of natural gas and oil, historical, and the geologic formation is is all know it, but with the technical exploit of the fracking in the United States begin to be observed and exploited. You have in the east oil wind, and the west natural gas wind, or wet, in the middle you have wet hydrocarbons. The quality of the resources are very well. It's compared with the Vaca field in the United States. The area, you have two geologic formations. Vaca Muerta is the most known, and Los Molles is another geological formation. Is depth than Vaca Muerta. One is in 3,000 feet, the other in 6,500 feet. A good pressure of the reservoir, good average of TOC. Then you have a resource of good quality oil and natural gas too. The energy trade balance in Argentina was year by year from the 2000 worst. The country went from being a net energy exporter till 2010 to be a growing importer, mostly of natural gas and diesel imports. For our country, imports in hydrocarbons for $6.5 billion is an imbalance in the macroeconomic structure, very, very important. Then the potential of the fields, the unconventional fields, was considered as a possible solution to the problem of the deficit in the international trade accounts, but to consider the possibility to begin an export their country. The production from these fields, the oil production, began in 2016 from near 30,000 barrel days and 130,000 in 2020. The pandemic was very significant in the production of the oil in the country, but now the unconventional production is near 25% of the total production of the country, with conventional production in decline and non-conventional production is up. The natural gas production is more important to the domestic supply because is near 47% of the total supply of the country, but the COVID was more important in natural gas. The production of natural gas will get up from 2017 a cost of gross subsidies to the production. But you know, the production in non-conventional fields is very link it to the investment, the continuous investment that in 2019 collapsed. There is no investment in 2019 almost in all the oil industry, but that was more significant in the Vaca muerta. The prospect is in the this year we will not have a good production of oil and natural gas to the domestic supply. We will be a net importer, an important net importer this year and next year too. With this introduction, we research the possibility of future scenarios for the development of this field. The performance of recent years shows a shy start to development at Vaca muerta, possibly due to the effect of geological and technical learning in a context of strong macroeconomic imbalance of the country, with uncertainty in the investments needed to develop the pilot project and the massive projects, if considered acceptable. Falling demand in international markets, falling prices in uncertainty about the global economic recovery make the situation in the field more difficult. The estimate investment for a massive development of the resource are estimated around $10 billion a year. In the past 5 years, we not overcome 5 billions. It's very difficult to have this level of investment in this field to develop in a massive way the production of oil and natural gas. To develop Vaca muerta, we need continuous investment and access to low-cost financing. That is very difficult for Argentina. We have technical capabilities and human resources. That is a good. Is good for the industry. The infrastructure is not very well to access markets, all over international access markets, and we are not competitive in the international market to export. With these considerations, we evaluated 3 scenarios. The development Vaca muerta only for the domestic market and exports to neighbor countries, Chile principally, and south of Brazil, is a little to Uruguay too, and the scenario to export LNG to the world market. For the commercialization of natural gas is necessary to build infrastructure, pipelines and facilities of liquefaction. But in the case of oil production, it was considered that it can be placed without restrictions in the international markets once the internal market has been supplied. The evaluation was a classic economic evaluation, cost benefit. We consider investments, number of wells that will need drilled in the oil windows and in the natural gas window, the capex of this operation. And we arrive, that's official numbers from the Secretary of Energia in the country. We could arrive in 2030 to 900,000 barrel days of oil from Vaca Muerta 615 barrel days, with a growth by year in 5.2 and possibly export of 400,000 barrel days. The price of $65, and in the natural gas, the growth is more little. The production of gas in these scenarios are 119 million cubic meter days, mostly from Vaca Muerta. The same for regional markets, is the same production, but with imports of LNG. Argentina is now net importer of LNG in the peak season. In the scenario of regional market and domestic supply, it needs invest in pipeline from the field to the consumption center, Buenos Aires. And in the LNG export scenario, it's needed another pipeline and second pipeline. We need to grow up the production in Vaca Muerta and invest in the liquefaction facility for 7.5 million tons per year. The results in terms of production in the period of 20 years, we recovered 10% of the technical recoverable resources and of oil and 20% of gas. From this point of view, and take into account the quality of the resources, the project is feasible, is possible. We don't see problem. But the probability of making the investment to arrive at this level of production in the medium term is low, and with prices of $65 for oil and $3.5 million BTU for gas natural, the economic evaluation has a negative NPV of $11 billion. The internal rate of return is less than zero in the baseline scenario. The LNG export worsened these numbers, and the project began to have positive NPV for a rate of 12% and 20 years of evaluation, with prices of $75 barrel and $4.5 million BTU. The LNG export scenario is also positive, but lower than the base case. And the sensitive analysis of the lifting costs and development show a good reaction when it gets down, but the cost reduction up to be significant, of the order of 50% and 10% respectively for lifting and development costs to achieve positive NPV values. With these results, it seems that the reformulation of the Vaca Muerta project must be improving its economic performance and must be conducted. Carrying out a project of this dimension based on budget subsidies up to now is like this. Does not seem to be the best solution. Well, okay, thank you. And as president, I hope not have exceed my time. And I wait your comments and questions. Yeah, Roberto, you.
I can go last if anyone else wants to go.
I'm wondering, you know, maybe if I can, I have a little one for you, Gerardo. You know, I remember once we had this discussion a couple of months ago about how the specific regulatory provisions used in Argentina for regulating retail prices of crude oil, the Criollo barrel scheme, have been used to somehow hedge and protect the local industry from the variability of prices under the COVID crisis. I'm wondering if you know whether there has been an ex-post evaluation of this policy about the cost it induces on consumers, on Argentinian customers, and the transfers that were associated with this policy. I don't know whether there has been an ex-post evaluation of that. I'm wondering if you could maybe comment on that.
Yeah, the comment is the next. Argentina has conventional areas to explore, but the policy is concentrated in develop a non-conventional Vaca muerta area, and in this way, the country interrupt the conventional exploration, the offshore exploration, and concentrated in a project is not yet economically viable with the international prices now. Then, to develop this country, this field, the country need subsidize the production. And for subsidize the production in the domestic prices of diesel and gasoline, the consumer pay. But in the subsidies of natural gas, and in the Argentina, the natural gas is the main source of primary energy, is the budget that pay is is not the consumer only, and it's very, very hard for the economy sustain this level of subsidies that are needed in other sectors of the economy. And the hopes of the industry to be in my country said to be the second agriculture possibility. You know the main income of exports in the country are grains and
yeah.
The second income is expected to be Vaca muerta. It's a cow dead. For one side, cow leaf, and for the other side, cow dead. And cow dead is not works with the productivity of the fields now. The quality of the resource is good, but the productivity is not competitive, and then is a very hard cost for the economy and the corporate interest of the industry to get subsidy harm the economy. And okay, we can wait better prices in the international market to be competitive, or we need to change the point of view and make another thing like attract capital to explore conventional fields, offshore fields, or in the worst case, import.
Thank you very much.
Thank you, Gerardo, for the great presentation. It is a topic that I find it very fascinating. And I've been following the storyline in Argentina for almost over 10 years in my career with IHS before. So it is. Thank you so much. I learned a lot, and I find the exercise very interesting. And certainly very important at this moment of the energy industry, because it is going to be crucial for Argentina to work around the issues you discussed. So my question for you is as follows. I noticed that you mentioned the issue of infrastructure, such as pipelines to offload more gas from Vaca muerta. And we know that unconventional wells have a shorter cycle. So you invest $10-15 million per well, and then the decline is going to last a few years only, like 2-3 years. So you need to keep refreshing that investment each year to sustain a certain level of production. So my question is there, and you did mention that attracting capital is the crucial bottleneck. So is there a challenge in investing in a new pipeline that takes 20 years to recover, right? When the capital investment in the wells is not made, right? So you don't have a huge reservoir of gas that will produce for 20 years anymore. You need to build a new pipeline and then trust that people will drill for gas, right? Is this an issue at all, or do people assume I can just drill it, right? So that was one question, because we know we're discussing the pipeline to Brazil, so to the south of Brazil here, and this is a question that I have. The other one is with regards to policy and the controls. Is there a need, in your view, to promote more exports from Argentina? Is that a bottleneck on attracting more investments as well? Or you think that, if I understood correctly, the international prices are not there, right, for exporting a lot? So those were my two questions.
Thank you, Roberto. The infrastructure, the infrastructure is a big issue. And I not mention the compromise of the country in the national determined contribution in the Paris agreements, where Argentina compromised the reduction of its emissions by 2030 and to be zero carbon net in 2015. And you say very good that the infrastructure adds a period of amortization of 20-30 years. And in the country, we have a very big discussion about who is that take the risk of build the infrastructure, the state, and subsidize avec the infrastructure the production of the producers in a state that don't have money and a very difficult access to international finances. It's a very big issue. I can't respond what will be the future about this. maybe, most probably, Vaca muerta will be an stranded asset, mostly in the future. But that's will depends of the decision of the policy, the big policy, not only energy policy. And the second question is about the exports. The numbers for natural gas export in the energy market are not good. Argentina with a $3 million BTU at wellhead for the producer can't arrive to Asia and North Europe with $6 or $7 final price. If you make the net back from the market to the wellhead, you arrive at revenue for the producer minus $1 a million BTU, with cost of transport, liquefaction, international transport, etc., etc., etc. Maybe in the spot market you can price some cargoes at better prices, but the development of a field of natural gas need a continuous export markets to amortize the investment. But for the shale oil, that no needs infrastructure, for the oil, the country could try to make more production to export in the international markets. It's more easy because we have a refinery capacity of 500,000 barrel days. We have our production now is 500,000 barrel days, and all surplus over 500,000 now is exported. And in a market with $65, $70 a barrel, the producer could put oil in the international market and make money.
Thank you. Gracias.
Okay.
All right. Thanks, guys. It was nice meeting you.
It's been a pleasure. Yeah.
Thank you very much. Thank you, Olivier, Brandon, Roberto.
All right.
Look forward to see you in person during a next true conference. Maybe one in Paris or elsewhere, but that would be a pleasure. Keep the finger crossed. Stay safe and well.
Next one is Tokyo, I think.
Yeah, you're right.
See you guys in Tokyo next year.
See you guys there.
Why not?
Bye-bye.
Bye-bye. Nice to see you. Have a great week.
You too.